In this, we will see an example in which we are going to solve a function value by the using of its graph. So we have a statement. The graph of a fruit fly population P is shown in figure this. First, the question is find the population after 20 and 45 days. We will see that it's 10 days and after 20 days we have to find out. The 20 days we have the population as 100. Here you can see that the line exactly lies over our point where our 100 value lies. So you can say that after 20 days we have fruit fly population is 10. We can use that if we put the value 20, that is also the value of x, we will get 100 population of fruit fly. So this is approximation value of the solution of this graph. So next they were saying about the value of 45 days. When we have 45 days, what will be the population of fruit fly? So here same we will use the approximation. You can see that here lies over 45 and again we will use the approximation value in our vertical line, that is our population. So you can see that here lies over 300 and between this it will lie over 310, 320, 3430 and here lies over 350, and when it cross this line it will be 350. So you can see that it is a bit closer to 350. That means we can say that at 45 days the population of fruit fly will be 340 because it is not crossing or intersecting the line of 350. You can see it over here. So we will move towards our second part, that is B. What is the approximate range of the population function over the time interval 0 to 40, 0 to 50? So they were saying that if it passes over the 50 days, how much will be the population of our fruit fly? So you can see that in this point at 50, it is really closer to the 350 value, but it is not crossing it. You can see it. Let me erase it so that you can clearly see all these. So here you can see that it is trying to or nearly closer to that 350, but it is not crossing it. So Our 340 value is a bit lower than that, and it is a bit higher than 340 value. So we can say that here lies our 345, because 340 is on 40 days, sorry, 45 days, and when it is crossing the 50 days we have 345 value. So in part B we can say, then when we have 50 days, then the population of fruit fly will be 345. That all based upon our approximation. So in this way we will complete a graph of a function. Next I will give you a quick overview of a numerical function. We will use the statement to represent the numerical function. Musical notes are pressure waves in the air that can be recorded. Okay, musical notes that can be recorded, and you know that all the waves belong to pressure or pressure waves, and we can record the pressure of that waves. The data in the table is given: recorded pressure displacement versus time in seconds of a musical note produced by tuning fork. Okay, a tuning fork is produce that note, and for the time being, with the time, we measure the pressure of each wave. The table provides a representation of pressure function over time. We first make a scatter plot, then connect the data points from the table, we obtain the graph. They were saying that we have to plot only the points, then we can join those points to obtain our graph. In this we can see that we have a lot of values that is produced by our tuning fork. You can see that when our time is 0.00091, we have a temperature in negative, that is minus 0.080, and it lies in air, and I can use any other value because I'm giving a quick overview. Because whenever you are given any example of this numerical, then either you have to experiment on this to get all the data of this, or maybe they already provide you this data so that you can easily use this value to plot a graph of like this. Okay, it uses the all the pressure values along the vertical line and the horizontal values along the horizontal line, because you can say that our pressure is dependent on time. If we have the value of time, we can conclude our pressure values